Let's begin with question 39. We're in the area of a triangle section. What is the area of the right triangle with side lengths 5 and 7? So we have some key information here. We know it's a right triangle with side lengths. So when we're looking at a triangle, here, if this is the right angle of that triangle, and we know that the side lengths are these two lengths here adjacent to that form the right triangle, and then we have this that is called our hypotenuse. Just so that we have our terms right, that's going to help us. Now when we're finding the area of a triangle, we use the formula A equals 1/2 base times height, and this is going to be our base of 7 and a height of 5. So we can plug in those numbers. We have 1/2 5 times 7, which is 35 over 2, and that is 17.5, and that's answer choice B. Question 40 says, given the figure below, what is the area of the equilateral triangle ABC? And we need to know that an equilateral triangle means that all three sides are the same length. And so we are given this side length of 10. That's going to make this side length 10 and this side length 10. Now we're looking for the area, and just as in the previous question, area is 1/2 base times height. So we've got to figure out what our base is and what our height is. Now it's easy. We could look at, for example, because this is on the bottom, and say this is our base of 10. But what about the height? Remember the other one, we had the height here and the base here with our 90 degrees. We don't have that with this triangle. It's not a right triangle. But we can draw and form a right triangle coming down here from this angle, from the angle here, and that forms a 90-degree angle. And this dimension here is our height, but we don't know for sure what that is right off, but we can tell we're given, let's work with this one, right, this triangle here. In this case, we have a hypotenuse of 10, which is really one of the sides of the equilateral triangle. And what about the length from there to there? That is because we split this side length in half when we draw from this angle. That's going to make that length 5. So let's just draw this triangle that we're talking about here, where we have the right angle. We had that hypotenuse of 10. Half of 10 is 5. That's what we found for the base of this triangle. And then we have a height, h, that's our unknown. We've got to find this value first, and then we can plug it in. So right triangle, we have two sides, one unknown. We can use the Pythagorean theorem. So we're going to go with h squared plus 5 squared equals 10 squared. So that gives us h squared plus 25 equals 100. Subtract 25 from both sides, and so h squared is going to equal to 75. We're going to want to take the square root of both sides. H is going to be equal to the square root of 75, and we can simplify that. That's 25 times 3 under the radical, so that can pull out a 5 on the square root of 3 for h. So now we're going to take this value and we can use it back in our original problem. A is going to be equal to 1/2. Now we're using the base of 10 here. That's our original problem. And we just found the height to be 5 on the square root of 3. So when we simplify here and do our multiplying, we can go ahead, we could divide the 2 into the 10 and make that 5. And then 5 times 5 gives us 25 on the square root of 3. That's answer choice B. Question number 41 says, in the figure below, the vertices of triangle ABC have xy coordinates. What is the area of triangle ABC? So we have our triangle here, and this is similar really to the previous problem, except for we have these coordinates, and so we need to find the lengths of these. One thing I always like to look at, let's go back to our original formula of area of a triangle, 1/2 base times height. What do we have and what do we need? So let's look at our base first, and I'm going to use the base of the triangle right here, and we can use these coordinates. along here, this is our x-axis. So if I look at the x value of 1 for C and 4 for B, that means the distance between from C to B is going to be 4 minus 1 equals 3. So this length here is 3, and that's our base. That is equivalent to our base, and I'm going to go ahead and we'll start plugging in what we have. We have 1/2 times a base of 3. Now what about for H? This is not a right triangle again, but we can form it making a perpendicular line from that base from the angle opposite that. That gives us a right triangle right here. This is going to be our height H. Well, how can we do that? We can make use of these values on the y-axis. So you can take a look at C or B because they both have y values of 1. And look at the A value, or the point A's y value is 4. So from A down to here where B and C are, it's going to be a difference of 4 minus 1, which is 3. So we have a height of 3. So in this case, we turned out with both a base and a height of 3. Simplify here. 3 times 3 is 9 over 2. 9/2 is our area, and that is answer choice C. Now let's take a look at area of other figures, starting with question 42. In the isosceles trapezoid given below, the parallel lines are 8 inches and 14 inches long respectively. What is the area of the trapezoid in square inches? So we have a little bit of information here in our wording that we need to be aware of. We are given an isosceles trapezoid, and what that means, this is the figure of a trapezoid where we have opposite sides here that are going to be parallel. This side is parallel to this side, and then we have our other side length. It says there it's an isosceles, so that's going to mean the side lengths are the same. We're given here at 5 inches, so this one is also going to be 5 inches. And then they also give us the dimensions of 8 and 14. We need to be familiar with the formula for the area of a trapezoid. It is going to be 1/2 times the height times B1 plus B2. And what's B1 and B2? We can name these in any order. It doesn't matter. If I say that's B1, then that's B2, or this could be B1 and B2. It doesn't matter. We're adding them. Now, what about the height? The height, what we're going to do is from this vertex up here at the top down to a right angle perpendicular here. This is our height. The height of the trapezoid. So it looks like we have values for B1 and B2, but we need to know H. So how can we find that? Let's take a look. If we know this is an H value, but there's also an H value right here. And look at what is formed in the middle of these between here. We have a rectangle, and then we also have 2 triangles on the end. So we're going to make use of that to find our value of H. I'm going to draw this out as a triangle, and let's see if we can find. We know this length is 5 because it's an isosceles triangle. We've got this value of H. We don't know for sure what this is, but can we find this value that will help us, because this is a right triangle, then we can find the value of H. Well, when we break this up, we know the side length here is 8. So from this point to this point is 8. So what does that make here? If the total is 14, that leaves 14 minus 8, 6 inches that are distributed evenly on both of these sides. So we have 6 left over. So this, we said it was 14 minus 8, which equals 6. And divide that by 2 because we've got an amount over here and an amount over here. That's going to make that 3. And so that will also make this length 3. And we'll just put that right there. So now, always when we have a right triangle with 2 side lengths looking for an unknown, we can use Pythagorean theorem. So I'm going to say h squared plus 3 squared equals 5 squared. H squared plus 9 equals 25. Let's subtract 9 from both sides, and we get 16. Take the square root of both sides, and H is going to be 4. So we've got a nice number of 4 for our H. I think we've got everything to plug in now. So A is going to be equal to 1/2 times height, which is 4, B1 we said was 8 plus B2, which is 14. Let's simplify. 8 plus 14 equals 22. We can divide this 2 into the 4, and then we're left with 2 times 22, which is 44, and that is answer choice C for our area. Question 43 says, given the measurements in the figure below and that angle A equals angle D and BC is parallel to FE, what is the area in square units of the hexagon? A hexagon being a 6-sided figure. So when I'm looking at a question like this, I don't off the top of my head know a formula for the area of a hexagon. So I'm going to look at how this figure is made up. Are there other figures inside this figure that I do know the area of, and then maybe I can group them together to figure out the total area. So because we know that angle A is equal to angle D and B and C are parallel, what about if we cut this figure in half? And I'm going to look at this top half over here. It looks like I have something that looks like this that we just worked on, a trapezoid. And then we have the bottom half. So we've got 2 of these, right? We need to keep that in mind. And I have not drawn mine to scale. But it's something like that. Forget that. We can erase that part. But we have something that looks like this. And let's see what we're given. So again, this is point B. This is point C. This is point A, and this is point D. Now we're also here given this dimension of 10, and that is equivalent to this whole length of this figure. So that's going to be equivalent to AD, which is 10. Now another thing we want to look at is look at this dimension from here to there. That is 10. We could put that's equivalent to right here. And we talked about that previously. That's going to be half of that is right here. And on a trapezoid, that is H. And so if the total dimension there is 10, well then half of it is going to be 5. So looking at our formula for a trapezoid, remember it was 1/2 H, B1 plus B2. Looks like we have an H value. We have, if we call that B2, we need B1. We don't know what B1 is. And how could we find B1? Well, we know right down here from this point to this point is 6, and that's the same as the dimension for BC. So that's going to be our B2 that we need. So let's plug into all this. And this is only for 1. This is for the top half. I'm going to say 1/2. Our H value was 5 times B1. Oops, I'm sorry, I labeled that B1. That should be I labeled it B2, it should be B1, because up here it's equal to 6. So we have 6 plus 10. Let's simplify here. We have this 5 times 16. I'm going to divide 2 into the 16 and gives me 8. 5 times 8 is 40. But this is just for the top half, so I need to multiply this times 2, and that's going to give me 80, and that is answer choice D. Now we're going to do a couple of midpoint questions, starting with number 44. What is the midpoint of the line with endpoints 1, 2, and 7, -2? So we're looking at midpoint, which we can kind of think of as the average. It's the middle point in this line that we're looking at. So we have the 2 points. When we're finding the midpoint, I like to look at both the x values and the y values. So if I'm going to look at the midpoint here, I'm going to take both of these x values, x1 plus x2, and divide that by 2. It's just an average. So let's look, and it doesn't matter which one we use as x1 and which one is x2 because we're just adding, and just to be consistent there. So the first point has a value of x as 1. The second point has a 7 for its x value. Let's divide by 2. 1 plus 7 is 8 over 2, and that's going to give us a 4. Now, if we're trying to go really fast, which we are, we're trying to go as fast as we can on these questions. At this point, here's a point where I want to look at my answer choices. I know the x value is going to be 4, and so that's going to eliminate A and B. I'm still left, I've got to distinguish between C and D, but I've gone down from a 25% chance of getting right to now 50-50. But we know how to work this, so we're going to keep going. So to find our midpoint with our y value, now let's look at the y values. We're looking at the positive 2 plus a negative 2, divide that by 2. 2 plus a negative 2 is 0 over 2. That is equal to 0. When we divide anything into 0, we're going to get 0. So that's going to make the point 4, 0, which is answer choice C. Now, another thing you could do if you cannot remember this, I don't really see this as a formula to remember, but it is knowing how to manipulate the numbers. You could take your thing and you could plot these points. So if I had the point 1, 2, 1, 2, and then the point 7, it's going to be somewhere out here, negative 2, it's somewhere down here. So if we're looking at this line right here, we know in general our midpoint is around here somewhere. So you could possibly take a look at these points and see which ones make sense. For example, if you had gotten a point that was negative 2, 0, you know that would be eliminated. So that's something you can do. Always try to think of different ways you can work questions. And if you just can't remember something, think about what makes sense. What is this giving us? So that is our first question on midpoint. Now let's take a look at question 45. The number line below is the graph of which of the following inequalities. So we're looking here at an inequality question, and what we want to look is see what is graphed. So the first thing I like to look at is we have solid points, so that's going to be an equal, less than or equal, greater than or equal. When we look at our answer choices, all these have a greater than or less than equal, so that's not going to eliminate anything. Let's look, we'll start over here on the left hand side. What is this telling us? It says anything less than or equal to 0. So for example, if I have the point negative 1, that works, right? It is less than, so x is less than or equal to 0 right here. Now what about here we have on the right hand side? Anything greater than or equal to 2 is going to work. So like if we have the point 3, that's in there, right? Now what would fall in between here would be like 1. 1 doesn't work for any of those. So the thing is, we have to combine x less than or equal to 0 and x greater than or equal to 2. So we can look at these choices. C and D are just those individually. So they're not going to work. We've got to see how our greater than or less than, how our inequality signs are made. So what I like to do when I combine these, I like to start with putting x in the middle, and then I'm going to put my smaller number on the left hand side. And what did that say? In this case, x, the inequality is pointing at the x. So I'm going to point at the x, and that's 0. So 0 is greater than or equal to x. I know that sounds opposite of what we said, but we interexchanged the 0 and the x in these. So we almost like we flip the inequality. Again, we can almost stop right here. Look at our answer choices. It's going to be answer choice A because here we have 0 greater than or equal to x. But let's continue to look at how we work the problem. Now for our x greater than or equal to 2, it's a little bit easier to do this one because now I'm going to look at my x and I can rewrite it the same way, x greater than or equal to 2. And so that matches with answer choice A. Now we've got a couple of questions in the next section, which is number and quantity, and we're going to start off with absolute value with question 46. And we're asked to evaluate this expression, and so I'm not going to read it all out, but we have these absolute value bars the symbols that we have to use. So first I treat the absolute values almost like we do parentheses when we're evaluating a big expression. I'm going to evaluate inside the absolute value first, and then we'll work our way into all the other things. So first, let's keep our absolute value bars, and we're going to have 3 times a negative 2 gives us a negative 6. minus 6 times 4 is 24. And I'm going to close out my absolute value, minus another absolute value. 2 times negative 1 is a negative 2, plus 3 times 5 is 15, absolute value. We're still working through. So now I have the absolute value of negative 6 minus 24 is going to give me negative 30. Absolute value minus absolute value bar. Negative 2 plus 15 is 13. Absolute value. Now we can evaluate the absolute values. So absolute value of negative 30 is 30. Minus absolute value of 13 is 13. So 30 minus 13 is 17. And that's answer choice D. Question 47. Same way we're going to evaluate all of this, I like to rewrite and work through each one. So I've got a negative 3 on the outside. Absolute value of 7 minus 5 is 2. Absolute value plus a 2 times the absolute value. Negative 3 minus 2 gives me a negative 5. Now let's evaluate with our absolute value. We still have this negative 3, but I'm going to convert. When I evaluate the absolute value of 2, which is 2, I change this to a parentheses, plus, rewrite the 2, absolute value of negative 5 is 5, and we're putting that in parentheses now. Now we can now we'll evaluate by multiplying. Negative 3 times 2 is negative 6, plus 2 times 5 is 10. Negative 6 plus 10 is 4. And that is answer choice D. One note that I do want to mention, anytime you have absolute values, when they are in expressions like something like this, don't immediately eliminate your negative answer choices thinking, oh, it's an absolute value question and it's not going to be negative. When you start doing the other calculations of multiplying and adding or subtracting, you could end up with an overall negative answer. It's just when you take the absolute value of a number, it's always, that part's what's always going to be positive. So don't let that throw you. Evaluate all the way to the end. Now let's look at multiplying and dividing variables. Question 48 says, what is the product of this expression? And so I'm going to evaluate each like term as I come to it. First, I like to look at my coefficients out in front. These are the number values. So I've got 3 times negative 2. That's going to be negative 6. And this is another question where I'm going to start looking at my answer choices, because look, we have different values of our numbers. We have A and B are negative 6, but C is a 3. It's not going to be 3, and it's not going to be a positive 6. So we've eliminated answer choice C and D already. Now, the only way we can multiply variables is if they have the same base of the variable. So here I have an X, and here I have an X. So what I'm really doing is I'm going to group these together. X times X to the third. And now let's group our Y's. Y squared, which is right here, and Y cubed. Now, for same base variables, we can add the exponents. So let's keep our negative 6. For the X, it's going to be, we assume a 1. 1 plus 3 is 4. So we have X to the 4th. For speed's sake, we can begin looking at the X term. And I'm going to look at answer choice B, where it's X to the 4th. That's X to the 3rd. It's going to be answer choice B, but let's keep going. You could stop at this point if you're working the test and you are sure that you have done this right as far as we have, and we have. But now, to know how to work the problem, we're going to look at the Y values, which it's Y squared times Y to the 3rd. 2 plus 3 is 5, and that gives us the correct answer of negative 6, X to the 4th, Y to the 5th, answer choice B. Question 49, we've got to evaluate this expression where we have division. In multiplication, you add the exponents when you have the same base. With division, you subtract the exponents with the same base. So with the division, this is one way that you can work this by keeping everything like this, but we're going to subtract the exponents of the same basis. So let's look at x first. We'll start with x. So we have x to the third on top minus a -2. That's going to be our x. So, and I've got that right there. So we have the -2. Now let's look at our y's. We have y squared on top, no y's on the bottom. And for z, we have z to the first on top, an understood 1, minus that 3 on the bottom. So let's rewrite with our exponents all worked out. We have x to the 3 minus a -2. That becomes a plus. So 3 plus 2 is 5. Y squared, z to the 1 minus 3 is a -2. And if I look at my answer choices, we're writing them with positive exponents. So this z, which was to the -2, we'll put that down in the denominator as a positive exponent. And what matches that answer choice is answer choice A. We've looked at exponents in the previous questions, but let's look at them a little bit more. Question 50, what is the following expression equivalent to? This is similar to what we've done, but we've also got an exponent of 3 around this entire numerator here because of the parentheses. We know that. So when we raise an exponent to another exponent, we're going to multiply those exponents. But first we need to handle this 3. So I'm raising each of these terms. So I'm going to rewrite this as 3 to the third times x squared to the third times y to the third. And all that is over xy squared. So now I want to raise each of these terms here. So 3 to the third, remember, is 3 times 3 times 3, which is 27. Now we can begin looking at our answer choices. And on that alone, I can see that D is the only one. We have no other numbers in this that are going to make this number out in front. So D is our answer. But I'm going to continue working it so that in case that's not how it works with the answer choices in the question you have. Again, we're multiplying exponents in this case, so we will have x to the 2 times 3, which is 6, y third, all over xy squared. And we can do some simplifying now. So we still have the 27. We have x to the 6th on top and x to the 1st on the bottom. We're going to subtract. 6 minus 1 is going to give us x to the 5th. And we have, for the y's, 3 and 2, so 3 minus 2, which gives us 1, which is y, just y. And that matches our answer for answer choice D. Question 51, what is this now? So we're going to raise each one of these terms to the third. We have a squared to the third and b to the third. And looking at our first term out here, 2 times 2 times 2 is 8. That's going to eliminate all the choices except for D. D's going to be the choice again. But again, let's say you had 2 choices with A. Let's keep looking at how to work this. A is going to be 2 times 3, which gives us a to the 6th. And then we just have the b to the third. That matches with answer choice D. This is a kind of question that you can get to where you're working it really quick. Just make sure you're multiplying your numbers correctly. A lot of them aren't very difficult numbers, but you just need to make sure you're multiplying them out properly, but you can get this done quickly. So that's question 51. Now let's move to the imaginary numbers with question 52. It tells us that if I squared is equal to -1, and that's part of our definition of an imaginary number, then what is 2 plus I squared, that quantity squared? So we're looking at 2 plus I squared, and we are given this. Sometimes they give this to you, other times you just have to know it and be aware of that. But the first thing I want to do is I want to multiply this out. This is the same as 2 plus I times 2 plus I. And so we can multiply using the full method. 2 times 2 is 4. 2 times I gives us 2I. Plus I times 2 gives us 2I. plus I times I is I squared. Simplify here, and we're going to have 4i, 2i plus 2i, plus I squared. And it told us I squared is equal to negative 1, so we're going to rewrite this as 4 plus 4i plus a negative 1, because I squared is negative 1. So we can now simplify. We have 4 minus 1, which is 3, and that's just 3 plus 4i. We can't simplify that anymore, and that is answer choice D.